Welcome to Chapter 12.2, Scientific Notation. This chapter, most of the section that was to be covered, I tackled in 12.1, so the only thing we're going to work on is scientific notation in this chapter. The beauty about it is the scientific notation is something we've all kind of see, so we just got to get used to the method behind it. Usually scientific notations come about because we have a gigantic number, maybe something like 4,208,000,000. So a really big number. And when we write papers, usually in the science world, they don't like repeating their large numbers over and over and over. It's repetitive. So they like to condense it into a nice form, especially if the number is very, very large. So they put it into scientific notation. Essentially what they do is they pick out significant digits. So significant digits are things other than 0. So 4, 2, and 8 are other than 0. The 0 squished between two significant digits becomes significant, but all these other zeros are not significant to us. So the only significant digits to us are 4, 2, 0, and 8, and that 0 is only included because he's between two other non-zero numbers. So once we have our significant digits, we go to the left, the leftmost digit. Okay, we're looking at 4. To the right of it, put a decimal point. And we're going to multiply it by 10 raised to some power. And that power is the number of places to the right of the decimal point in the original number. So if we have the decimal point right after the 4, here's one digit, 2, 3, 4, 5, 6, 7, 8, 9. So we'd have it raised to the 9th. That might seem funky to you. So let's get a really small number, one that's a little bit more manageable. Maybe something like 210. Nice number. And let's be crazy. Let's put this in scientific notation. So pull out your significant digits, all right, 2 and 1. To the left of the leftmost significant digit, we'll put a decimal point to the right of it. Okay, my lefts and right screwed up. So we got 2.1. And we're going to times it by 10 raised to the how many places to the right of that decimal point. 1, 2, so to the second. Now let's see. 10 squared is really 100. So we have 100 times 2.1. Well, 1 times 0, 1 times 0, 1 times 1, placeholder, 2 times 0, 2 times 0, 2 times 1. Add them up. How many decimal places were involved? Well, 1. And hey, look, we got back with the same number we started with. So we got 210. So that's what scientific notation does, except it's really obnoxious for us to write out 10 to the 9th, multiply that all out, and then times it by 4.208. So we'll just take for granted that it always works. Now let's go ahead and write a little bit of a note to ourselves. When the exponent is positive for scientific notation, that means we have a very big number. So the exponent is positive if the number is large. And you can think about it. We went to the right of the decimal point. That was one of the strong points. We moved to the right. And whenever we go to the right on a number line, we always get bigger. So right, positive, it's large, kind of associate those words together. So let's go ahead and see where we want to go backwards. Let's say we have decimal notation, and we want to go back to, we have scientific notation, we want to go back to decimal notation. So we start with something like, I don't know, 5.601. And it's times 10 to the 11th. So when we're starting with scientific notation, just write down the same numbers again, the significant digits, without the decimal point. And from where the decimal point is, we are going to count 11 places to the right, because we're getting bigger. And when we get bigger, we go to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, and that's where we would stop. So for all those missing blanks, we can fill in the insignificant digit 0. So our answer, if we want to write it out nice and pretty, we have 3 zeros, comma, 3 more zeros, comma, 100, comma, 570. So we have 570 billion 100 million. Pretty large number. So that's how we go backwards. So this is for large numbers, when the exponent is positive. Let's go ahead and write in scientific notation when we have a very small number, something like point and lots of zeros. So we're going to do the same idea. Pull out your significant digits. Now, the significant digits are things other than 0 unless there's a 0 squished between two significant digits. So for our case, we just have 917. Go to the leftmost significant digit and put a decimal point to the right of it. So same directions as before. Now though, to count how many decimal places we have, we're going to have to go to the left. So here's where we're kind of putting the decimal point. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a really small number. And when we are small, we go to the left on the number line. And usually that's where the negatives are. So we use a negative exponent to represent a really small number. And if we want to go backwards, let's convert to decimal notation, and let's start with scientific. So let's say we have 5.213 times 10 to the negative 7th. What we're going to do is write down our significant digits without the decimal point. And I'm going to kind of use my scientific notation to help me out. I have it to the negative 7th. So the negatives are to the left. We're getting smaller. We move to the left. 1, 2, 3, 4, 5, 6, 7. So essentially we have a decimal point that we're going to need to place, because this is a small number. And we have 1, 2, 3, 4, 5, 6 zeros. And I'm not sure if I can fit my zeros in. 6 zeros, and then our significant digits. And that's the decimal notation of our scientific number. And that's all.